So we're going to complete some practice exercises that use conditionals. So we're going to start off by writing a program to determine the smallest value of 3 values entered by the user. So I'm going to create a new class. I'm going to call it min of 3. And I'm going to use a main method because I'm going to want to run this class, run this program. So I want to ask my user to enter 3 values. I'll ask them for each one in turn. And I'm going to read them in. Again, at first, I always need a scanner object in order to interact with the user. And I'm going to use the next int method to read them in. So I'm going to be reading in integer values. So I'm going to say int value 1 gets scan.nextInt. And then I will tell the user to enter the second value and read that in. And tell them to enter the third value and read that in. Now, what I'm going to do is, instead of putting my code to find the minimum of these 3 values inside of my main method, I'm going to write a separate method. So let's think about how the method header should look. So what should the return type be? This method, the purpose of it is to find the smallest value out of these 3 values that have just been entered by the user. So what should the return type be? It should be an int, because you're going to give me 3 integers, and I'm going to tell you which of those is the smallest. So I'm going to give you back the smallest integer. Okay, so it's going to be a public method. It's going to return an int. I'm going to maybe call it something descriptive like find min of 3. And what should the parameters be? So what information or inputs does this method need to complete its task? Well, it needs the 3 values that it's finding the minimum of, right? So it needs n1, n2, and n3. Now I have to make one change to this method header. I have to make it static. Right now I'm not going to explain why. This is one of those, trust me now, we will learn about it later type situations. Okay, so I have 3 formal parameters, n1, n2, and n3. Those are my inputs into the method. And now I want to think about how I can use my things that I've just learned about conditionals to compare these 3 numbers to each other. So I'm going to use an if statement. So I'm going to start off by saying if n1 is less than n2 and n1 is less than n3. So if that's the case, if n1 is smaller than n2 and it's smaller than n3, then we know that n1 is the minimum. So if that's true, if what's inside this if statement is true, I'm going to return n1. Okay? Now, what if n1 was 2, n2 was also 2, and n3 was 3? Would this if statement evaluate to true or false? Well, it would evaluate to false, right? Because if n1 and n2 are both 2, then n1 less than n2 is going to evaluate to false, and this whole thing is going to evaluate to false. But 2 really is the minimum of that set of 3 numbers. So I actually don't want to check if n1 is less than n2. I want to check if it's less than or equal. And same thing with n3, because that'll cover me in case some of my numbers are the same. Okay, now that's how I can determine if n1 is the minimum. Now, how should I determine if n2 is the minimum? Well, I can basically do the same thing. I can check and see if it's smaller than the other 2 numbers. Now, I could do that this way. I could have a separate if statement saying if n2 is less than or equal to n1 and n2 is less than or equal to n3. This will work to determine if n2 is the minimum, having 2 separate if statements. But really, from a logical perspective, I only ever want to evaluate the second one if this first one is false. And whenever you have linked conditions like that, so whenever you're saying, well, I want to check this first, and only if this first one fails do I want to check the second one, that's a good case for that's when you should use the else if. Because these are really linked, right? I want to check this first and then this. So whenever you have, again, conditions that are linked like that, where you only want to check the second one if the first one fails, you should use the if, else, if instead of using separate ifs. Sometimes that's not quite as clear to see when you should use separate ifs and when you should use if, else, if. It just kind of takes a little bit of practice to figure out, which situations are best for what. But really, the key rule of thumb there is if these conditions, again, are linked, if you only want to ever evaluate the second if the first one fails, then you should use the if, else, if. You'll use separate if statements if you always want to evaluate both. But we don't need to evaluate the second one if we find a match on the first one, right? If this first statement is true, we never need to evaluate this, so we shouldn't use separate ifs in that case. Okay, so now this will cover me if n1 is the smallest. This will cover me if n2 is the smallest. Now I could write a separate else if n3 is less than or equal to n1 and n3 is less than or equal to n2. Return n3. That will certainly work. This will cover me if n3 is smallest. But you'll notice that I still have this compiler error with this method here telling me that I have to return an int. And why is that true? Well, it's possible from Java's perspective that all three of these conditions could be false, right? We know from a logical perspective that one of these has to be true, right? One of these three numbers has to be the smallest. But from Java's perspective, if you have an if, else if, it's possible that all three of these conditions could fail, meaning we would get down to here. Right? Because if we use if, else if, it's possible that none of those statements execute because we don't have a final default else. And so Java's saying, well, hey, what if you get down here, you haven't returned anything, and that's not allowed. Okay, so note that it doesn't matter if logically you know that one of these is always going to be true. Java doesn't know that. Java doesn't evaluate from the logical perspective. It just evaluates from a compiler standpoint that, hey, if you just have an if, else if, it's possible none of those things are true and none of these branches will be executed. Okay, so a couple different ways around that. The best way around that is to just make this an else. And what I usually do when I'm using an else is I put a comment that represents the logical condition that this applies to. Right, so we know that this if statement represents n1 being smallest, this one represents n2 being smallest, this one represents n3 being smallest. We can just use the else because we know that if this is false and this is false, this must be true, right? We do kind of want this default condition to apply. But it's helpful for a human reader to kind of have that specified in the comment. So I usually do that when I'm just using an else, is I put a little comment that indicates what the logical condition really is. And now here you'll notice that our compiler error went away, because remember that if we include a final else, you are guaranteed to have one branch execute. So either this one, or this one. Okay? So now we can invoke this method. Sending in value 1, value 2, and value 3. Here, value 1, value 2, and value 3 are the actual parameters. Remember, that means that when invoking this method behind the scenes is as if there is code n1 equals value 1, n2 equals value 2, n3 equals value 3. And then we can print that. All right, so let's go ahead and run this program. Enter in the first value, 1, 2, 3. The minimum of these numbers is 1. If I enter in 3, 2, 1, the minimum is still 1. If I enter in 3, 1, 2, minimum is 1. If I enter in some repeated values like 1, 1, 2, or 1, 2, 2, etc., it always finds the correct minimum. Okay, so there's an example of using if, else, and also just another reminder of some of our terms that we've learned, like formal parameter, actual parameter, return type, etc.